In this video, we're going to be finishing off our symmetrical counting problem from the last video, so let's get started. So, if any of you have solved the problem, you might have realized that the answer is not 2 factorial or 3 factorial divided by 3. And this is because, if you recall from last video, we have a keychain with three accessories on it. We have a keychain. Now, if you think about a keychain, how many ways can we arrange the keys? Well, obviously, it's a symmetrical item. So, over here, the same count can be rotated 3 different times, and we only want to count it once. So, if we just do 3 factorial, that's counting it 3 times. So we divide by 3 because it's overcounting, and we're dividing by 3 because this is 3. We're doing 3 times the number of rotations we want it to be. So in the last video, we covered tables, and you can't really flip a table over. I mean, if you flip a table over, you would have the legs standing up, in which you can't really do anything on. So if we're being realistic here, a keychain can be flipped over. And if a keychain can be flipped over, that means there's times 2 overcount on it, right? So if there's times 2 overcount, if it's double the overcount, we obviously want to find a better way to handle this. And I'm pretty sure we've already handled this because a keychain A, B, C, D can be flipped over C, A, D, B. That's how it can be flipped over. So that's 2 different ways that we can have this. So we multiply by 2 for that reason. So 3 factorial is 6, and 3 times 2 is 6. So the answer is just 1. And we're going to go over another keychain problem to give an example. So let's say we're going to use the next slide. Let's say I have a keychain in which there are 8 objects, right? Alright, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so 8 keys / any accessories you have on the keychain. So this is just 8 factorial divided by 8, because 8 rotations, since it's symmetrical, we're counting 6 times. We only want to count it once. So, and every single arrangement can be rotated 8 different ways, which it's counting everything 8 is not 8 different ways, but it can be rotated 8 ways, which we don't want it to be. So obviously, we just want to multiply by 2 as we did in the last time, because a keychain can be flipped over with opposites. So this is A, and this was B. This would be B, and this would be A. So we can flip it over. So this is just 8 factorial over 8 times 2, which is 8 factorial over 16, which is our answer. So that's really all we have to do when it comes to symmetrical counting. So an overview of symmetrical counting: if it's a table or something that can't be flipped over, that's our formula. If we can't flip it, it's n factorial divided by n times 2. Or I can just do a 2n at the bottom. So those are 2 formulas, but a good thing in counting problems is to never use formulas. If you understand counting, it should be pretty clear why a keychain has that formula and why a table has that formula. Because a table we can't flip, and a table is counting every single rotation n times or k times, which we don't want. So that's an introduction to symmetrical counting. Hopefully this video helped. And yes, that is symmetrical counting.